Hey there, ladies and gentlemen, boys and girls. Welcome back. Today, we're going to talk about our second type of age dating. This one's a little bit trickier. Today, we're going to be talking about absolute age dating. I almost blanked out there. Absolute age dating. So, this is different than relative age dating, and I highly recommend that if you have not already, watch the video clip that I sent in the that I also attached on the about Half-Life, because that's going to make a big deal. You're not going to understand the practice problems here unless you understand a little bit about Half-Life. All right, so here we are. We are going to talk about absolute age dating. All right, so now we're shifting up. Last time was relative age dating. This time we're going to talk about absolute age. Man, you would think I'd get better at this. That's pretty sad. All right. Anyway, today we're going to talk about absolute age dating. Now, this is going back to talking about fossils and fossil records, but instead of just telling it based on, the rocks and which ones are older and younger, we're going to give actual dates. How old is something? And we're going to take advantage of a property called half-life. All right. We're going to take advantage of a property of radioactive particles called half-life. Now, this is a physical science concept. And this concept here is basically that it's the amount of time it takes for a radioactive particle, for half of them to decay. In the video, he calls them disappear. They don't disappear, they just turn into something else. Now, when we do absolute age dating of fossils, we're actually looking for a very specific radioactive isotope. This one is called carbon-14. This is also known as carbon dating. Carbon dating is a way to measure this radioactive isotope called carbon-14, which is an atom that has 6 protons and 8 neutrons. All right? Carbon-14 in organic molecules or organic compounds like trees, animals, plants, different things like that. Based on how much there was and how much there is now, we can tell how old that object is, because carbon-14 slowly decays into nitrogen-14, and its half-life, we represent half-life with that symbol there, is 5,730 years. All right, that's how long it takes for half of the carbon-14 in our bones. This is where we find carbon-14 in humans. For how long it takes for half of those atoms to decay into nitrogen-14. Now, while we're alive, we constantly replenish that carbon-14 in our bodies. You see a little chart on the right. I don't need you to memorize that chart or anything like that. I just wanted to kind of show a little bit there, talking about how carbon-14 in the atmosphere is changed into nitrogen-14, changes nitrogen-14 back into carbon-14, which is then absorbed by trees, right, or into the grass, and then we either eat the trees, eat the grass, or eat the animals that ate the trees and grass. All right. Either way, we are getting carbon-14 into our diets, and then it's replacing the ones that we are slowly decaying into nitrogen-14 in our body. So we have a pretty good stockpile of carbon-14 in our bodies. When we die, we stop taking in carbon-14. So that carbon-14 in our body starts to decay into nitrogen, but there's no more new carbon-14 coming in. So depending on how much there was at the beginning and what percentage of that carbon-14 is left after a certain amount of time, can tell us how much time has passed. So I'm going to go through a couple of the problems here. I tried to pick 3 different problems that kind of covers everything. And I did one of carbon-14, but I picked some other radioactive isotopes just to make this a little more interesting, partially for myself here. So let's look at our first problem here, a couple word problems. All right, got to clear this here. All right, so here we go. A tissue sample, all right, contains 50 grams of radioactive sodium-24. It's very important for our cells. After 30 hours, the tissue sample only contains 12.5 grams of sodium-24. How long is the half-life of sodium-24? So it doesn't tell me how long it is. I need to figure it out. All right. But now, as you saw from the video, each half-life is how long it takes for half the isotopes to decay. So if I start with 50 grams, right, after one half-life, I'd be down to 25 grams. Now, I don't know how long that half-life is. I don't know how long that is yet. That's what we're trying to find out. All right. And then it says, okay, well, we're not at our goal yet. It says it contains 12.5. Well, we're not at 12.5 yet. Well, after a second half-life, half of 25 is 12.5 grams. Well, there's our goal. Right? Again, we don't know how long that took, but we know it took 2 half-lives to do that. One from 50 to 25, and then 25 to 12.5. Right? It said that 30 hours passed total. So how long was each half-life? Well, 2 half-lives, total of 30 hours. That means each half-life, again, lambda, that's the symbol we use for half-life. You can also use the T 1/2. It's the same thing. In this case would be 15 hours. 15 hours to go from 50 to 25. Another 15 hours to go from 25 to 12.5. All right. So let's try another one. All right, let's try this one. Let's go with green. All right. In this one here, if we start with 8 grams of barium-137, that's actually, if you've ever had digestional issues, intestinal tract stuff, you actually drink this stuff, barium. It's like this white milky stuff, and it makes, in X-rays, it makes your intestines all light up, and so you can see holes in your intestinal lining. Anyway, sorry. If we start with 8 grams of barium-137, after some time, only 4.5 grams remain. How many half-lives occurred? All right, so we're going, actually, I think this is a typo. I think I'd actually rather have this as, it's supposed to be 18 grams. Oops, we'll just go with that. All right, after 18 grams, if we start with 18 grams of barium-137, after some time, 4.5 grams remain. How many half-lives have occurred? All right, so this one's actually a little bit easier, I think. All right, so if we start with 18 grams, after one half-life, 9 grams would remain. Well, we're not at 4.5 yet, but after another half-life, 4.5 grams remain. There we go. We had 1, 2. So the correct answer is 2 half-lives have occurred in this case here. The half-life of barium-137 is 2.5 minutes, which means to go from 18 grams to 4.5 grams, if we want to add into this, that means a total of 5 minutes has passed. But that's a little extra bonus there. That's not what the question was asking. Okay, let's try another one. Hopefully I don't have a typo in this one, but there's always that chance. All right, so now let's do one with carbon dating. All right. A fossil sample started with 36 grams of carbon-14. Now, here's the first mistake I want to talk about. One thing people want to do right away is they want to use that number 14. That number 14 is it's an isotope. It's identifying the atom. So it's just one big thing. So we start our fossil sample started with 36 grams of carbon-14. When the fossil was discovered, only 4.5 grams of carbon-14 remained. How old is the fossil? All right, let's just go through that same technique again. Let's see how many half-lives. All right. So 36 grams to go to one half-life would be 18 grams down to 9 grams, 4.5 grams. So we have 1, to 3 half-lives who have occurred. But it doesn't want to know how many half-lives. It wants to know how old. Well, I told you up in the very beginning that the half-life of carbon or carbon 14 is 5,730 years. So it'd just be 3 times that half-life of 5,730. I want to make sure I did my math right, which is 17,190 years. Now, one thing I want to point out here is all these ones I've been doing and the ones I will be doing in this course are all nice, really easy round numbers. Notice it's not 17,192 years. That's because I'm going to keep this pretty simple. It actually is a gradual process, but I'm going to keep the math pretty easy. Maybe I would do half a half-life, but that would be as a challenge problem. All right. So in this fossil sample here, based on we know how much we started with, right? We know how much we started with. We know how much we ended with. We found out how many half-lives there were, and each half-life, right? Each half-life in this case was 5,730 years. That's information I gave you. I could Google that, and it would be absolutely the answer. It's not a mystery. And then I could find out that that fossil is 17,000 years old. All right, so I hope this helps with some of the problems as you kind of go through them. If not, make sure to message me and just ask me if you have any other questions. Otherwise, this is absolute age dating, where we can actually find out the actual age of the actual fossils. If you have any questions, just make sure you get back to me. Otherwise, good luck, and may the science be with you.